I think it's fair to say that weather impacts all of us, and weather impacts all of our businesses. And what we want to talk to you today about a way that weather impacts that you might not have thought too much about. You know about ice, you've probably slipped on it enough times, but ice accretion is actually quite crucial to built structures, and in particular in this case into the energy environment and into poles. And as we saw in, some of you might remember in Shetland last year, there was a bit too much ice, a bit too much snow, and things fell over. And that is a problem, and that we want to obviously keep away from. You'll know the Met Office. We forecast stuff. We tell you it's going to rain when it doesn't, and we tell you when it's going to be sunny when it isn't. But we forecast ice and snow, but we don't only do that. We also work with clients on a consultancy level to understand how to deal with it when it does happen. So when we get ice, what do we do about it? When you're putting that onto a structure, if you put a lot of ice onto a structure, it weighs a lot, and that has to be designed for. And actually, it varies from year to year, so you don't know what's going to happen. So you need to understand that it might not happen this year, it might not happen next year, but it could happen the year after. And when you've got structures going up for 60 years, you have to understand what is going to happen and what is likely to happen, so you can design it in. So some of you, I don't know if anybody's here from SSE, in which case close your ears, but you'll all have heard of SSE Transmission and the investment they're doing to keep the lights on in England. I'm from England. I'm glad the Scots are keeping the lights on in England. We did a feasibility study, and we looked at the structures, and we looked at the ice, and realized that there was a huge amount of over-investment going in building structures that were too over-engineered. Back in the Victorian era we were building structures that were well over-engineered. Now the problem with that is it costs a lot of money, and as consumers we get that in our electricity bills, but also it costs time. To build more over-engineered towers and things costs more time, and we're in a rush to get the wind farms and the generation into the network so it can be used and we can get use of it. There's no point generating it offshore if we can't then get it to the homes and businesses that need it. So what are they working with at the moment? Well, it's basically back of an envelope stuff. It's a map that we created some 30 years ago, even before I was born. I am not this old. And it draws like that. Now it's brilliant, except for it's not really brilliant. And when you look at the Western Isles, how do you figure out what the loading is? Because your lines are too close together. You've got absolutely no chance of figuring out. SSE requested us to build a new map. Now, this isn't really that straightforward. We're not just going to repeat what we did 30 years ago. Now, we have to look at the issue of compliance. We have to look at the issue of standards. We can't just create new standards. New standards take forever to come into fruition. So what we need to do, we needed to update the meteorological data they were using, not the standards. So the whole thing was very much about looking what the needs were. What were they trying to use the data for? What were the decisions they were going to be making in the design? So what were the poles? What were the heights involved? The types of product assets they were looking to use? All of these things had to be looked at. And then we had to look at the balance between science and engineering. Now, my science colleagues are bright. They're intelligent, and they love everything to be perfect. Engineering colleagues, maybe a bit less bright, not as particular about getting everything perfect. But there is a balance to be got there. We need to do good science, but that is materially of value to the users that are going to use it, in this case, the engineers. So we're going from the prehistoric to the modern day. Now, I'm going to get into a little bit of science here. I'm going to run through it really quickly because I don't understand it. There's a lot of different reasons for snow and ice, but in Scotland and the UK, pretty much it's wet snow or ice rhyming. You can read it. I'm not going to explain it. And so we focused in on those two. The modelling, now that is really about two things. One is, what are we trying to model? Well, we need to model poles, we need to model pylons, we need to model conductor sizes. They've got loads of conductor sizes, so you can't model all of them because this takes a huge amount of computing power. So we did the small, medium, large, and then they can draw a line in between them and figure out how it all works. And then it's the data, and we'll talk about that in a second. But it's then putting it into a model that works, and there's quite a few of these, but they're done in places like Norway and sort of Canada and Greenland to get lots of snow in a way that we don't over in this country. So we have to look at what works, and we have to look at how it all comes together. So we did a lot of that type of work, understanding what was needed and how it worked. The data side, the Met Office, excuse my French, has shitloads of data. We have loads of it. And we don't know how much we've got, but we've got lots. But you're looking at what's appropriate for the particular purpose. Now, we do data a granularity of 2 kilometre grids, but that was too granular. It was taking too much time and it wasn't going to add value. So we did the 8 kilometre grid, and then you look at the various weather parameters you want. Particular wind and moisture are quite important, but all of those parameters are important, but those two are the most complex. So what challenges did we have? Well, not me, but my colleagues. The model required correction. The models actually didn't work. When we looked at them, the models that had been used previously actually didn't work for the UK, because in Scotland we don't get as much ice as we do in Norway, and it works well for the bigger parameters, but not when you get to the lower volumes. So we had to make some corrections there. We had to look at the mean speed, the wind speeds, because the wind speeds, when you do it at height, different than when you do it lower down, even when you're talking about 33 to 13, because of all of the way that the wind blows around. So there was a lot of corrections needed to be done. The big problem is we didn't have any way of validating the model. So, because we don't have a lot of data about ice on conductors. So what we had to do is use what we had, and then with SSE, they're going to be doing some validation over a longer period of time. So that was the challenges. Now it doesn't want to work at all. Now it's confused. That's it. So we generated the maps. We did the 13 and 33, we did the 14 and 40 and another one in between. We did the EVAs. Now, I don't know if anybody knows what EVAs are, but basically what you're looking at is extreme value analysis. That makes me sound clever, doesn't it? Basically what you're looking at, what happens in a 1 in 3 year, 1 in 50, 1 in 150 year, and 1 in 500 year. So if we were all around for 500 years, what's the worst case that we're going to go? Now, typically I think these networks are built to 1 in 150. And then you look at different distributions who don't care about. But my colleagues did. And then we do the wet maps. So we end up with maps. So we're moving from this back of an envelope to the maps you see on the other side. And they're basically looking at different heights and different conductor sizes, and you can start seeing it. Now, this is where it gets interesting, because now they can start using it, can they? Well, yeah, but they've got pictures. So now they want something that they can actually use, which is where my colleague Ant comes in to explain the bit you're really interested in. So he's going to now talk to you.
Thank you very much, Phil. So the Met Office has 1,800 staff, of which a good 600 are scientists, and of that, there's about 100 of us that are applied scientists. So we work with clients to solve their weather-related problems. And in terms of the problem that's relevant for this project, we've done the science, and I'd like to thank Karen Walter, KTC, Laura Hume-Wright, and Philip Sansom, who did all the numerical modelling. We need now to share that data with SSEN. And so we went to SSEN and we said, how would you like to use the data? And firstly, they said, can you show us some examples of the data? And we sort of have, I guess, with that, the maps that Phil showed. Can you then also send us all the data in a readily usable digital form? We'd then like to be able to store that data on our systems. We'd like to sort of process that information to see the data alongside our asset information. And then we'd also like to share that information with specific colleagues in our organisation. And so then I thought, well, how would we, the Met Office, as scientists, ordinarily share this data? The easiest way to share it is in our complicated modelling system. We just export an image of the map, and in some ways, compared to the existing standard, it is an improvement, but you can see because there's much more complex modelling, it's quite hard to sort of pick out the signals in that data. We could contour it up, but then again, you're just going to end up with all sorts of contours in there. it doesn't really bring the data to life, and it doesn't really make it sort of easily usable. We'd also, well, we then say, well, actually, let's send you the data. So the main data format that we use is NetCDF4. The modeling itself was carried out on a rotated pole coordinate system, which probably most users would sort of scratch their heads at and go, well, how might we use that? It also, because it's multi-dimensional, it contains data at all heights and conductor sizes. So it's a neat file to use in a scientific context, but it's perhaps not neat otherwise. And it's in this rotated pole coordinate system, so we need to turn it into standard WGS 1984 lat long. And to get it into that format, scientists say, oh, just run this Python script. And so all of this is really convenient for research scientists to use, but it's quite challenging for the majority outside of that sphere. And that was me earlier on this summer when I was asked the question, you know, we need to show, send, store, see, and share the data. So that got me thinking. So I thought, well, let's look at the barriers to usage of this data, instant usage of this data. So the rotated pole coordinate system that the Met Office use, and we use different flavors of it for different things, is incompatible with the WGS 1984 standard lat long, which is annoying. The reason we use rotated pole as well is because we're 56 degrees north, and we like lat long grid cells in our models to be pretty much square. And by the time you reach 56 degrees north, you're sort of, the shape's kind of no longer square. And so what we do is we bring the equator up to the center of the domain that we're interested in this case, the UK, and or Scotland in particular. And then you've got nice square grid cells. But to get it to be usable, if you try and load that data into ArcGIS, you're going to get the dreaded transformation warning. A data and transformation cannot be found. The data may draw with an offset. Oh, no. So surely, if we could do something with that data to make it easier for the users to use, they don't have to go through this sort of nightmare scenario to sort it out. So what we can do, of course, is we can run the Python script and get the series of points, the array of points, but really, SSE really wanted to see it as a nice grid on their maps. And so this is how we overcame the barrier. First of all, we wanted to get it into a more usable format. We wanted to transform the rotated pole data to standard coordinates, to generate some nice polygons for each grid square, and then perhaps just to sort of take apart the multi-dimensions and save each layer as a separate each dimension as a separate layer. And so I ran the Python script. There's my points, and you can see them sort of tilted slightly to the lat long grid. What I was aiming at was to get a nice sort of grid that looked like that. And the way that I did it was I created the rotated pole coordinate system as best I could within ArcPro. I then literally dragged and dropped it into WGS 1984, and then I used the sort of the tool that just the rubber sheeting tool that just gently sort of molds it to fit to fit where I wanted the cells to be. So we did all the pre-processing. So that actually there's an example of the rubber sheet there. And then to bring the data to life, I uploaded all the data to ArcGIS Online to access it via an ArcGIS Hub site. And this really brought the data to life, made it much easier to show. I didn't need to send it because it was there. It's all stored there. You can see the data, and then they could share the data within their organisation. So on the right there's the Hub site that I created. So the data itself, I uploaded all the data to ArcGIS Online, and then in an afternoon created a Hub site which points to all the data. All the layers as well have detailed metadata, so that there's just a very brief summary up there. And And also, you can control which users can see that data as well. And so users of the hub can then search for layers, so they can say, I want the data at 13 meters, I want a particular size of conductor as well. Use that data, they can examine the data, they can download the data, as you can see there, in a range of standard spatial formats. They can share that data with colleagues. And of course, they don't need to worry about the rotated pole coordinate system because the data is already readily usable in WGS84 that long. If they want to, they can view the data in tabular form as well. And one of the best things that really brings the data to life is the ability to view the data in the ArcGIS Hub map view as well. So the data itself is 8.8 kilometer grid, so it's relatively coarse, but for the purposes of this, because they're looking at planning whole sections of overhead line, it's an appropriate resolution for that data. And they can filter the data, they can style the data. And of course, you can drag and drop the data into ArcGIS Pro. So here's an example of an overhead line that goes over to the Isle of Skye, and you can see there that there's a section around the middle of the map there that actually doesn't have any data. So it shows the limitations of the data. So in terms of what we've done, as an organisation, we're regarded as experts in atmospheric modelling, but one of the things that we really struggle at is to deliver these complex model outputs in readily usable formats. But ArcGIS has enabled us to kind of break through all of those barriers and to permit a comprehensive digital management of these quite complex ice accretion model outputs. So we do all the complicated science. We also sort out coordinate systems, get the data into a readily usable format, pop it onto ArcGIS Online, create a hub site, so that then the client, in this case SSEN, can now confidently select the model output that they want, view it directly alongside their asset information to support improved power line network design. I'm just going to hand back to Phil now, who's going to say a few final words.
Yeah, so we've done it once, so we're going to do it again, or we are doing it again, and then we're going to do it again, or we are doing it again. So we're doing the corrosion map, we're doing an overhead line noise map. That's a nice one. How much noise do you hear from your overhead lines? We're doing dynamic line rating, which I'm not going to explain to you, but the Met Office is very much into this. So we're not just about delivering the data, we're also about helping people use it and helping people apply it into their particular circumstances. Ant's the brains, I'm the brawn, but my email's up there, so if you want to talk to us afterwards, great. If you want to contact us for any more information on anything to do with the Met Office, then please feel free to do so. And I will say goodbye.
Thanks very much to Phil and Ant from the Met Office. Really interesting look into their ice accretion models. So for the next 20 minutes or so, Richard and I are going to discuss how we can better manage data within the ArcGIS system. Now, I think it's well understood across business, and especially in the GIS community, that a good foundation data set is required to produce great analytical results. I've lost count over the years of how many requests or great ideas have sprung up, which just simply aren't possible due to the quality or availability of data. And I'm certain that this is felt in the audience here today. We're accepting of this, and we take it as a fact. But what happens when we get that key missing piece of data? Excitement rises, tunnel vision creeps in, and we rocket towards our destination, flexing our GIS muscles, thinking I can finally remove the chocks and go all in. We blaze a trail of scratch data, test data, or just generally intermediary stuff that clogs up our folders. When it's all said and done, we sit back and we think, yes, that was a complete success. Then we're asked to repeat it, to tweak it, to document it, or revisit it in some fashion, and we're faced with a sea of files with names like test_19, or something equally as helpful. This is where the importance of data management comes in. So the principle should be no different. We consider the level of detail required in our data, but we can often overlook the level of detail required in things like our folder structures and naming conventions. Now, I get it. Data management isn't the shining star of GIS, but we mustn't forget that it is essential. This is only compounded when we're trying to hand off work and to collaborate as well, so time can be wasted through having to revisit projects, relearn what test_19 is, tidy things up and so on, and then explain through a handover what, why and how to the next person. Now, time is precious. It's the single most important or valuable currency that we all have, so why would we waste it? Not to mention the potentially endless amounts of wasted data that could be floating around out there in the ether from sharing outside of synchronized environments. Having a gold standard data set or one truth can be influential for everybody involved. So how can we start to be more cognizant of this and better our working practices, ultimately saving us all time and money as we move GIS into the future? Well, thankfully, we're not short on out-of-the-box options. So if we start inside ArcGIS Pro, we can take advantage of using Model Builder, for example, to capture processes and refine things like our naming strategies, output destinations, including those scratch and intermediary folders. And we can start to remove the time sink on the back end from having to revisit and remember every minor detail. We can take this a step further and we can start to use data management tools inside of Model Builder to do the not-so-fun administrative side of things, such as creating those folders or databases, as well as adding annotations and notes alongside the tools and steps. So building in complexity, yes, but really bringing us toward a more concise and robust process. Let's go another step further and touch on custom Python scripts, for example, run as tools. We can create an all-encompassing process, creating everything from those folder structures and databases all the way to project files based off of templates, not to mention the analysis that can happen in the middle. For me, I think this is an important part. We can automate based off of pre-planned layouts, so no more marginalia worries for me. Let's not forget, though, we can also utilize tasks in Pro, which are a great way of providing a guided, interactive workflow that steps a user through our designed process. These may be the most preferable option if handover times are limited, as we can implement a best practice workflow or create a series of interactive tutorial steps. Now, a task is created in a task item in an ArcGIS Pro project, and a project can contain multiple task items, and a task item can contain multiple related tasks. They can be shared as a task file which can be imported into and opened in another project. So a great example from one of our graduate, James, can be found on the Esri UK blog. Now, when it comes to ArcGIS Online, I believe we're already a few steps ahead. Workspaces are already shareable and synced through collections like groups, but we can still face those same challenges when it comes to being data tidy. So it's worth mentioning that things like naming conventions and the general admin that was stressed in the previous slides, they still apply here. ArcGIS Online is a powerful tool and one we should be using to achieve that gold standard data set, or the one view of the truth. We can quickly share and collaborate spatial information, all the way up to the ingestion and on-the-fly analysis of real-time data through ArcGIS Velocity. What I can't give you is a standardized naming convention that suits your business or your organizational needs. But what we can facilitate is the software and the processes to enable a good standard of data management. Now, I think it would only be right to touch on some ways to extend these capabilities beyond the out-of-the-box solutions, if you like. Now, as with much of the ArcGIS system, we're able to reach into extensions and capabilities that allow us to tailor processes or free us up to more functionality. So let's start with ArcGIS Notebooks. For those of you that aren't aware, notebooks are an integrated Jupyter notebook that we can use to really start customizing workflows from basic geoprocessing all the way to advanced data science workflows. One powerful way to use notebooks might be through data engineering and visualization, which we can see in this notebook taken from the latest Spatial Analysis MOOC, or massively open online course. These courses are a great way to improve your GIS expertise, and as a bonus, they're completely free to access. In this particular example, we're taken through a number of steps, from loading and preparing relevant data sets to carrying out calculations and geo-enabling to prepare a usable GIS output. Notebooks are available in both desktop and online and are free to get started with, but it's worth mentioning that some ArcGIS Online processes will use credits, much the same as analysis in MapViewer. So just be sure to double check before you start analysing the world on a repeating hourly schedule. Another option we have to extend some data management capabilities is the data interoperability extension in ArcGIS Pro. This is an integrated spatial extraction, transform, and loading toolset using SAFE's FME technology. For me, this really blows the ingestion capabilities wide open for ArcGIS Pro, giving us the ability to work with almost 430 formats, ranging from things like CAD files, HTML, Word docs, to Salesforce and SAP HANA reader writers, and it even includes virtual reality modeling languages. So opening the extension launches the FME workbench, which allows you to create your data translation workflow. In this example on the screen, we have a relatively simple workflow that uses a reader to load a SketchUp 3D drawing file. It then applies some transformers to scale the coordinates of the SketchUp model from millimeters to meters, and then shifts it to the target altitude. The affine warper then uses a set of construction lines to move the model from the Null Island in the Atlantic to a target location. Finally, it filters the geometry of the objects before using an FME writer to export it as 3D features to a file geodatabase. So sticking with the theme of extending capabilities, Richard's going to introduce us to data pipelines. Richard.
Thanks, Dan, for providing us with that great roundup of the existing data management tools available in ArcGIS Pro and ArcGIS Online. This has hopefully refamiliarized everyone here today with the variety of workflows available in the Esri stack and potentially introduced our audience to some new ones. What I plan to show everyone here today is a new product in ArcGIS Online, but I will start by asking everyone in the audience to raise your hand if you've ever used Model Builder. That's a good start. Now, raise your hand if you have ever heard of data pipelines. That's still a few of you, so if you've got your hands raised, keep them raised if you've ever built your own data pipeline yet. Excellent. So a lot of us will learn something today. Data pipelines is a new native data integration capability of ArcGIS Online. That's quite a mouthful. So in short, it allows you to connect to and process data from various sources. Similar capabilities have been available through developer technologies like notebooks and Python, but these could be tricky to grasp for a large proportion of users. Data pipelines makes it faster and easier to access, prepare, and integrate data to make use of in ArcGIS Online. This is thanks to its easy-to-use drag-and-drop interface. I'll give you an example, which I'll demonstrate later. You are given a CSV file of data categorized by local authority, but is inherently non-spatial. If you want to create a web map, you will first need to join it to a dataset that maps local authorities. You may also decide to apply a filter or calculate a field. Well, all of this can be done in one place within ArcGIS Online, thanks to data pipelines. The first question you may have then is why would you use data pipelines instead of Model Builder or FME, which we mentioned earlier? Well, what data pipelines does is provide the functionality to all ArcGIS Online customers, and particularly those customers who don't have access to an ArcGIS Pro license, to create reproducible, no-code data preparation pipelines to streamline their workflows, all within ArcGIS Online. So, what can you do with data pipelines? I've already mentioned you can use CSV files, but there is so much more. You can ingest either hosted data or any data shared publicly that is accessible via URL. Data pipelines allows you to connect to datasets in external data stores like Amazon S3 or Snowflake. You can filter and clean your data using a variety of data processing tools. And you can calculate new fields and make use of the native Arcade editor. Let's dive into the demo I promised. Once I've launched data pipelines, I begin by selecting an input dataset. I choose my non-spatial CSV file listing statistics for wind turbine use for each local authority in Scotland. These statistics were provided by the Scottish Government. Data pipelines allows you to preview the data at each manipulation step. We can see that the data has been categorized by each local authority, so this data is definitely mappable, but we need to utilize multiple data pipeline tools to get there. I will save this data set for later and instead add a different input. I will search for the county and local authority boundaries of Great Britain. This is a data set available on the Living Atlas. Living Atlas data can be consumed in data pipelines, just like in other places in ArcGIS Online. Clicking Preview, we can see the data in tabular format and confirm it has the same area codes as our turbine data. We will utilize this later. Since this data is spatial, we can preview the data on a map. What I want to do now is limit this data set to just local authorities of Scotland. I opt to choose the tool Filter by Attribute, which is one of the many tools available in data pipelines. I apply an SQL expression to filter the dataset to just records that have an area code that contains the Scotland prefix. I will now preview the data again to confirm that the filter is doing what I want. I am now happy I have a spatial dataset to join to my non-spatial turbine data. I select the tool and join the joining fields for each dataset. When I preview the join, it now shows the fields from my turbine data in my local authority dataset. Data pipelines also has the capability to calculate new fields, and this includes a native arcade editor. The field I wish to calculate is a new statistic, turbines per hectare, rather than turbines per square kilometre, as this is used by some communities. In the arcade editor, I paste in the code I wish to use and then add in the fields to make it work for my data. Previewing the data one last time shows this new field. I am now ready to create an output of this data. I have the choice to overwrite a layer or append to an existing layer, but in this case, I simply wish to create a new layer. I click Run, and the Run Details pane opens and shows you any messages associated with running the workflow and indicates the status. For example, writing records. And that is that. Once it is run, the data is then free to be added to a map. So in true Blue Beta style, this is one I prepared earlier. I'll finish by sharing some key considerations from my experience using data pipelines. Data pipelines requires you to be a creator user with the data pipelines privilege enabled. Data pipelines offers, for the first time, a no-code environment to process data in ArcGIS Online that is easy to pick up for users of any experience. The ability to save and share pipelines means that processing tasks can be easily repeated and collaborated on with organizational members. Now the cost. Data pipelines usage is charged in credits per minute. Credits are consumed at a rate of 30 credits per hour and are consumed whenever a session is active, even in an idle state. So don't go making yourself a cup of tea and leave the session open. Lastly, Data Pipelines is currently released as a public beta with full release expected in late 2023. A popular feature requested that is not currently possible is the ability to schedule when a pipeline will run. This is confirmed to be on the roadmap for a future release. So to conclude, I hope you saw in this short presentation how data pipelines could be a really great tool for all of us to use for data preparation and integration in ArcGIS Online. I'll now pass back to Dan to take us to the end.
Thanks, Richard. So we've kind of seen the ingestion side of the data management equation so far, if you like, but what about engaging audiences? Well, we can do this through ArcGIS Hub, like the Met Office have mentioned. And for those of you that aren't aware, ArcGIS Hub's an easy-to-configure community engagement platform. And really, it's about organizing people, data, and tools through information-driven initiatives. Organizations of any type and any size can use ArcGIS Hub, including government agencies, non-profit groups, academia. And we can really start to maximize engagement, communication, collaboration, and data sharing through Hub's initiative-based approach. So what if we look at this with our data management hats on? I think this is a great tool to use when we want to share data and create open data portals. We could also build modern websites around topics of interest or work with teams of people, including members of the community, as well as manage progress towards shared initiatives. Now, ArcGIS Hub is available at 2 license levels, Basic and Premium. So Hub Basic is included with ArcGIS Online, and it delivers data sharing and site creation capabilities. And Premium is available as an additional subscription. And this enables organizations to create and manage initiatives and collaborate with people outside of the organization. So that includes community members, partners, other agencies, all while using identity. We're seeing ArcGIS hubs being deployed in a wide variety of scenarios, one of which is in the utility space, with Ofwat driving water companies to make their data more open and accessible to others. So an example of this can be seen here with the Yorkshire Water's DWMP, or Drainage and Waste Management Plan, which shows how data sharing and collaboration is possible using Esri's core platform. It provides an easy-to-use, easy-to-publish solution for both internal and external stakeholders, and helps organizations communicate the necessary requirements when becoming more transparent in their sharing of data. So another great example from the Met Office is their climate data portal, where we can explore and download climate data sets in a range of formats. Using Hub, the Met Office have successfully deployed an interactive open data portal, which not only documents the work that they're doing, but also helps them succeed in empowering the GIS community to access their data. We can now use their data in our own processes, which has gone miles towards helping facilitate further geospatial analysis. So in summary then, we've covered really a range of topics today, and we started with how we can think about the challenges of data management. We then looked at some of the commercial off-the-shelf options to help us in our journey, and how to extend the ArcGIS system through the likes of notebooks and the data interoperability extension. Richard then took us through a new feature to the ArcGIS system, data pipelines, and we've just discussed how to collaborate and share our work through the use of ArcGIS Hub. So thank you all for your time today. We hope you've enjoyed today's session. Please come and find us in the lobby afterwards if you have any questions.